understanding how atoms finally bond. Yes, we took them to understand how um, the atoms in the periodic table are grouped based on the number of valence electrons that they have. Right, group 1 have 1 valence electron, group 2 have 2 valence electron, and others up to group 8. And then we also saw that those that are not in group 8, they all try to attain stability by following two rules: the octet rule and the duplex rule. The duplex rule is basically for those in period 1, meaning those that have only one shell, the helium and the hydrogen. Right, they have only one shell, so what they can do is either to attain a maximum stability of 2 on their K shell, which is the only shell they have, and the K shell can only have 2 electrons, and then or maybe 1 or 0. But the others, right, they have more than one shell, so they are dealing with the other shells. For our basis, we say that we are going to have the idea of a configuration of 2,888. So any other shell should have a maximum of 8 electrons, right? 8 electrons. So aside the group 8 element, the other ones want to attain 8. So they begin to lose or gain electrons accordingly in order to match. We also learned that those in group 1, 2, and 3, let me just show you the periodic table again. Those in group 1, those in group 1, this is group 1, 2, and 3. They tend to lose their electrons in order to become stable, because if group 1 have 1 electron in their valence shell, and then they have to fight to get to 8 by trying to fetch 7 electrons, that's too much. So they just basically lose those electrons, right? So these group 3, these 3 groups contains mostly metals. And metals, what do they do? Basically, they readily give out electrons. They readily give out their electrons to attain their stability. And if you go to the non-metals, right, they are hungry for electrons. So instead of them losing their electron, they rather gain to because carbon from group 4, we have 4, right? It says they need an extra 4 to become stable. If you come to group 3, nitrogen, for example, they have 5 electrons, so they need 3 more to get to 8 on their valence shell in that order. So that's how they form their distance. So let's see how they actually form a compounds out of that. So we are going to use some basic element. Like, let me use sodium. This is sodium, right? Sodium atom. But then the stable form, the sodium ion, to form an ion, it become Na plus. We talk about that, right? Because it's in group 1, it's going to lose 1 electron. If you lose 1 electron, it become Na plus. So group 1, 2, and let me take another element from group 2. This is magnesium atom, but then the magnesium ion, right, would be Mg2 plus. Magnesium is in group 2. It has 2 valence electrons, and then those 2 valence electrons are actually going to be lost, so that they will now have 2 plus at the top there. So group 2 element, group 3 element, let me use aluminium atom, and aluminium atom is going to be Al3 plus. Right, so what they are doing is that this guy, sodium is losing 1 electron, magnesium is losing 2 electrons, magnesium is aluminium is losing 3 electrons. This one is just representative of all the 3 groups, right? If you go to carbon, right, it's a carbon C4 minus. If you go to nitrogen will gain -3, right? It has 5, it's in group 5, so you need 3, so it will take in 3. It's not negative, it's not written like that. They make sure that the sign comes after 3 minus, right? Now if you come to let me use oxygen for those in group 6, they will need 2 more, right? 2 minus. And then those in group 7, I can use any of them, F minus or Cl minus, right? This is how they form their ions. But then we learn that you see that these people are giving, the metals are giving out electrons, and the non-metals are seeking electrons, right? So in the formation of the bond, this is what happens. The metals and the non-metals can come together, and then while the sodium, the metals are giving out the electrons, the non-metals on the other hand will receive the electrons. When they do that, then they combine, then they form the stable thing that we are talking about, the stable compounds that they come about. So let's say if I have sodium atom, for example, and I want to combine it with chlorine, for example. You know that sodium is in group 1, right? So the ionic form is Na plus, meaning that it will lose 1 electron. So meaning this one minus 1 electron, right? Minus 1 electron. And then this one, it will be seeking Cl minus. So meaning it's going to be looking for 1. So the electron that is lost from here, right? will now go to this guy to form this. Then these two will now come together and form NaCl. So this is the table salt, sodium chloride. This is how they are formed. So this one lose, this one gain. So the one that's lost from here is actually taken by this guy, and after they satisfy those conditions, then they come together to form a compound. So this is a bond between a metal and then a non-metal. Whenever you are forming such a bond where there is a transfer of electron, whenever there is a transfer of electron from one atom to another, whenever there is transfer of electron from one atom to another, right, that particular bond is ionic, that particular bond is electrovalent. So electrovalent bonding, so electron, right, valence electron, so a valence electron bonding. So it's like we are taking the electron from the valence side, right, the valence electron, and you are transferring it to another one. You are forming that bond. So electrovalent bond, or we just basically form ionic bond. Why? Because you can see that ions are coming together, right? Yeah, that's how ionic bond are formed. Whenever there's a combination between a metal and a non-metal, there are special cases actually, but then this is the basic thing that we are actually tackling. So we'll get into it, and then you see that chemistry is very interesting. Sodium and then chlorine come together, form these two electrovalent bond through transfer of electron. Here there is complete transfer of electron from metal to a non-metal. I can do the same for magnesium, which is 2 plus, and oxygen, right, which is 2 minus. So magnesium will lose 2 electrons, and oxygen needs 2 electrons. So they'll come together to form the MgO, magnesium oxide. These guys, that's how they form their compounds, right? This one, the magnesium loses all the 2 electrons, and the oxygen receives it. So whenever someone loses, someone has to receive, and they form the bond. That's another electrovalent bond, right? Now what about Mg2 plus and Cl minus? So if there is Mg2 plus and Cl minus, right, magnesium is giving out 2 electrons, and chlorine need only 1. So what about the other one? So this is what will happen. So if you have magnesium 2 plus giving out 2 electrons, and chlorine can have what? Need just 1. So why don't we bring 2 of the chlorine? So if this guy is losing 2 electrons, one electron will go here and 1 electron will go here to satisfy this guy. At the end of the day, you have magnesium and then Cl2. 2 of the, so this is the atomicity, this is the frequency of chlorine. We talk about this, right? So now that's how it happens. Against magnesium, you need 2 chlorine. If you want to, against magnesium, you need 2 chlorine. Each of the chlorine need 1 electron, but one magnesium is giving out 2 electrons, and each chlorine is giving receiving 1 electron, right? So when they come together, they are going to form MgCl2. You need 2 chlorine to form that. But there is another trick to all this cram. So if you know the ionic compounds, if you don't know the ionic component of it, right? Let me clear this thing. If you know the ionic component of it, like let's say calcium, you know calcium 2 plus, and then the other one O2 minus, right? So what is going to happen is that you basically, you see the number here, you bring it here, you send it here as the frequency. The number here sends as the frequency for this guy. You become Ca2O2, right? Come down. Whenever these two are the same, just write it like this. Calcium oxide, cancel the number if they are the same. If they are the same, right, you cancel it out. If they are the same, you cancel it out. You become calcium oxide. In exception of peroxide, we will talk about peroxides later. H2O2, those things are special cases. But then, whenever they form something like this, there's calcium oxide, right? So if I have magnesium 2 plus and I have Cl minus, so here when I say you have this minus, right, it just means like 1 minus, but you don't write the 1. So meaning there's a number 1 here and the number 2 here. But I'll send this 2 here and send this 1 down here. So what would they form? It will form Mg1 Cl, which number is coming there? 2. So if it is 1, we don't write it, so it's just MgCl2. That's how we're able to form this first one as the first. So there are 2 ways of seeing it. Magnesium giving out 2 electrons, and each chlorine has to need 1. So you have to bring 2 of the chlorine to come, or you can just see in terms of transfer of the numbers, right, the indices. So if by that, if I give you any other one like Na, and then Na and oxygen, right? Oxygen is 2 minus and N is Na plus. So this one here will go here, and then these 2 here will come here. At the end of the day, you have Na2O, something like that. Then we are okay. Let's try it with aluminium oxygen and see. Aluminium and oxygen, that will give me aluminium is, aluminium is Al3 plus because it's in group 3 and it needs to lose those 2 electrons, and oxygen is in group 6, and if it's in group 6 it needs just 2 to become stable. So now that these 3 will go here and then these 2 will go here, at the end of the day become Al3O2. We'll do the naming later, but I want you to see how they are joined together. After they are joined together, the next session we'll be looking at how to name these basic compounds that we have, ionic compounds basically, and all that. Sometimes these things can come together and there will still be some charges are left, right? Those are ionic compounds and all that. So we'll look at that. We'll look at naming of those things in the subsequent sessions. And now let's see that, okay, this is the naming of for this. Should I give you one to try? Yeah, let me give you one to try. Then you put the answer in your comment section if you know that's it, right? The most important thing is that you understand how it is working. Then so usually we are combining a metal with another non-metal, a metal and another non-metal. In the next session we'll look at a non-metal with another non-metal and see how they are combined as well. But right now let me give you a metal. Which metal? I have potassium, right? And I'm going to give you nitrogen. Combine them together. This is nitrogen and this is potassium. Potassium is in group 1 and nitrogen is in group 3. If you try this, what do you have? Try this, right? You can pause the video and try it, right? But if you are done, let's see. So you have potassium is in group 1, so it's going K plus, and nitrogen is in group 5, and in group 5 it just needs 3 electrons, we can need 3 minus, right? So what will happen is that this 3 will come as the frequency for this one, and this one will go as the frequency for this one. Become K3, and basically this is just to help you master it. This is what you have for this session. Yes, so let's meet the next session and look at bonding, how non-metal and non-metal bond. This one between a metal and a non-metal. Let's look at how a metal and a non-metal and another non-metal bond now. See you in the next session.